All right, let's get into it. Today, we're going to add a couple of essential tools to your scientific toolkit: density and relative density. Seriously, these concepts are absolutely fundamental if you want to understand the physical world around us. So let's open up that toolbox.
Okay, let's just jump right in with a classic question, one you've probably wondered about before. How is it that a massive steel ship, we're talking thousands of tons, can just float on the ocean? But a tiny little pebble you can hold in your hand sinks right to the bottom. The answer isn't just about weight, it's about how that weight is spread out. And the concept that unlocks this whole puzzle is called density.
And that right there leads us straight to our first tool. This is a real cornerstone of physics: density. You can think of it as the secret code that tells you how packed in any substance is. It is the absolute key to solving that ship and pebble mystery. So what is it exactly? Well, the official definition is that density is the mass per unit volume of a substance. But let's put that in plain English. It's really just a measure of how much stuff, mass, is crammed into a certain amount of space or volume. And this whole relationship is captured in a super simple but really powerful formula. Density equals mass divided by volume. This is the crucial part to remember. It's not just about how heavy something is, but how heavy it is for the amount of space it takes up. And we usually measure this in kilograms per cubic meter. Okay, so theory is great, right? But a tool's no good if you don't know how to use it. So let's stop talking about it and actually put this first tool, density, to work. And finding it is as easy as 1, 2, 3. Seriously. First, you find the mass. You just weigh it. Simple. Second, you figure out its volume, how much space it takes up. And finally, you just plug those two numbers into our formula. That's it. You're done. All right, let's do a quick one together. Picture this. You've got a glass block. We know it has a mass of 400 grams, and we've got its measurements right here. So just take a second. How would you even start to figure out its density? First things first, volume. We just multiply the length by the width by the height. Now, here's a super important step in any science calculation, and it's one where people sometimes trip up. You have got to make sure your units match. The standard is meters, so we've got to convert our centimeters, and that gives us a volume of 0.00016 cubic meters. And now for the final easy step, we take the mass, again, converting our grams to the standard unit of kilograms, and we divide it by that volume we just found. And boom! The density of our glass block is 2,500 kilograms per cubic meter. See, you've already mastered the first tool.
Okay, tool number 2 is a really clever shortcut. I want you to think of it less as a fundamental measurement and more like a comparison gauge. It's called relative density, and it's all about putting a substance's density into context.
So, if we're comparing, what's our benchmark? Well, the universal standard is water. Relative density is simply a ratio that tells you how dense something is compared to water. By the way, you might also hear this called specific gravity. It's the same exact thing, just an older term you might see. And here's the really cool part, what makes relative density so useful. Because it's a direct ratio, you're just dividing one density by another, all the units just poof. They cancel each other out. And what that means is that relative density isn't measured in anything. It's just a pure number, which makes it incredibly simple for comparing different materials. So the most direct textbook way to find it is with this formula. You just take the density of whatever substance you're looking at, and you divide it by the density of water, which for reference is a nice, easy number to remember, 1,000 kilograms per cubic meter. But here's a second way to think about it, and honestly, it's often more practical. Relative density is also the ratio of the mass of a substance to the mass of an equal volume of water. Now, this is a total game changer in a lab setting because, let's be real, weighing things is usually a lot easier than calculating their precise volume and density from scratch. Okay, we've got our tools. Time to head into the workshop. Let's see how we actually measure relative density in the real world, starting with a special piece of gear called a density bottle. Whoa, okay, I know what you're thinking. That formula looks like a beast, but don't worry, you do not need to memorize it. What's brilliant is the idea behind it. This is for measuring the RD of something tricky, like sand. All those little M variables, they're just different weight measurements. And by weighing things in a specific order, you can mathematically figure out the mass of the water that the sand would have displaced. It's just a super clever way of applying our second RD formula. Okay, let's flip the script a little bit and try a different kind of puzzle. What if you already know the relative density and you need to find the mass?
Let's imagine we have some acid. We know its RD is 1.20, and we're using that same density bottle.
So, here's our setup. Here's what we know going in. The empty bottle is 15 grams. When we fill it with water, the whole thing weighs 39 grams. So a quick bit of subtraction tells us the water inside has a mass of 24 grams, and we're told the acid's RD is 1.20. Our mission, find the total mass when the bottle is filled with this acid instead of water.
Okay, let's connect the dots. An RD of 1.20, what does that actually mean? It just means the acid is 1.2 times heavier than the same amount of water. We already figured out the mass of the water was 24 grams, so the mass of the acid has to be 1.2 times that, which is 28.8 grams. Then we just add the weight of the empty bottle back in and we get our final answer, 43.8 grams. See how it all just clicks into place? And just like that, you've officially added two super powerful tools to your scientific kit, the fundamental measure of density and the really handy comparison gauge of relative density. So now let's step out of the lab and into the master's workshop to see these things in action in the real world.
So one of the coolest real-world examples is this thing called a hydrometer. Just picture a sealed glass float that's weighted at the bottom. You just place it in a liquid, and how high or low it floats gives you a direct reading of the relative density. It is an incredibly simple but powerful tool that's used for everything from brewing beer to checking the acid in a car battery.
Okay, so let's put these two side by side one last time, just to really lock it in. Density is the fundamental property. It's the actual mass packed into a space, and it always has units. Relative density, on the other hand, is all about comparison. It's a pure ratio against water, and it has no units at all. So what's the big picture here? What do you absolutely need to remember? Well, three things. First, density is a fundamental property of literally everything around us. Second, relative density gives us this awesome, simple way to compare materials. And finally, mastering these two concepts is absolutely vital in pretty much every field of science and engineering.
And that leaves us with one final thought to take with you. Where else is this concept of density quietly shaping our world? I mean, really think about it. It's what allows engineers to build structures that are both massive and light. It's even how we can test the quality of the milk you drink. Once you have this tool in your toolkit, you'll start seeing its impact absolutely everywhere.